Hello, ladies and gentlemen, and welcome back. We are going to finish off the grade 8 Gauss paper in this video by taking a look at question 25. At the beginning of the winter, there were at least 66 students registered in a ski class. After the class started, 11 boys transferred into this class and 13 girls transferred out. So 11 boys in, 13 girls out. The ratio of boys to girls in the class was then 1 to 1. Which of the following is not a possible ratio of boys to girls before the transfers? Now, they said 66. It's actually at least 66. So that's interesting. Okay. I was wondering, because if it was exactly 66, then there would be only one possible answer. But we're looking, so it could be 4-7. There might be a way, if it was 67 students, maybe it's 4-7. If there were 70 students, it could be 5-11. But maybe there's some way it'll never be 9-13. And that's sort of a thing. That's what we're going for. And it's because we don't quite know how many students are registered. We know it's at least some number. All right. So we're talking about possible ratios of boys to girls at the start. So let's give a name to some of these things. So we'll say originally there were B boys and G girls. Okay? And so the total number of students, boys plus girls, so B plus G, has to be at least 66. That's something we know. That's something we're told. Okay. Then what happens in the question? 11 boys come into the class. 13 girls transfer out. So we increase B and we decrease G. And so just while we're keeping track of things, B plus 11 and G minus 13, that would add up to B plus G minus 2, because we lose more girls than we have boys. And so we know for a fact that that would be at least 64. But we're also told that this is now a 1-to-1 ratio, same number of boys and girls. So we get a nice little equation relating these two. Okay. So if you add 13 to both sides, B plus 24 is the original number of girls. Okay. So what have we got there? Well, we can say B boys originally and B plus 24 girls originally. Right? So that's what we can say there. Well, I'll write the word girls. Okay. Now, what are the possible values this ratio could have? So we need B boys to B plus 24 girls. But how do ratios work? How could this possibly be a 1-to-2 ratio? Okay. Well, if it were, we'd be able to set up an equation. 1B is twice B is 1 times as many as B plus 24. So what we're going to do now that we've got this more concrete relationship, that we've solved for the number of girls in terms of boys, and of course you could do it the other way around, but then you'd be subtracting. So here's what we're going to do. We've got possibilities. So let's work with these possibilities. So if the ratio were A, 4-7, or if the ratio were 1-2, 9-13, 5-11, 3-5. So 5-11, 9-13, and I think it was 3-5 at the end? Yeah, 3-5. Okay. So if the ratio were 1-2 boys to girls, then 1 times the number of girls would be equal to 2 times the number of boys. We get a nice little equation here. Okay? And this works for any ratio. Just sort of separate things off for a moment. You've got a ratio of x to y. So let me phrase it a different way. If I've got some actual amounts, u and v, and I know u to v is the same ratio as x to y, what we've got here is u over v is the same as x over y, and if you sort of multiply both sides by y and multiply both sides by v, is sometimes called cross-multiplying by people, you get uy is the same as vx. And so that's what we're really exploiting, is that if you've got values in the same ratio, you can sort of take the wrong pairs and you'll get an equality. So we'll use colors here for a moment. So u times the other one, y, is going to be the same as v times the other one, x. And that's all we're doing over here. B times 2, because we started with b to b plus 24. So b times 2 has got to be the same as 1 times b plus 24. Right? That's the property we're exploiting. And so now the question is, can we solve for b? And then if we can, which we should be able to, then figure out the number of girls, and then double check, do we have at least 66 students in our ski group? Because that's the condition that we haven't worked with yet. Okay, so we'll work out B, and we'll probably have to do a little bit of work. So I'll put B over here, and then we'll probably work out G again afterwards. So then we would have 4 times B plus 24 is equal to 7 times B. Or 13 B, no, 9, keep the first number in the ratio where it is. So 9, 5, 3. B plus 24 is 13B. 5B plus 24 is 11B. And 3B plus 24 is the same as 5B. All right, well, we can expand and say 4B plus 96, or B plus 24, or 9B plus, I don't know what 9 times 24 is, 216. 5B plus 120, 3B plus 72. And now we can say, all right, 7B, subtract 4B, is 3B, so 96 is 3B. 24 is 2B minus 1B is just B. 24 here. 96 divided by 3 is 32. 13 minus 9 is 4, so 219 is 4B. Sorry, not 219, 216 is 4B, and so 216 divided by 4, 54 boys. Not a problem there. 11B minus 5B is 6B. So 20 boys in that group. And then 5B minus 3B is 2B. 72 is 2B. And so the number of boys in that case would be 36. Okay. Well, we know the number of boys now. So for A, B, C, D, and E, we've got the number of boys. We can get the number of girls because the number of girls in the original group before any of the girls left was B plus 24. And then we can get the total by adding these two. So we had 32, 24, 56, 54, 20, and then 36. So I'm a little suspicious of the 20. I think that's going to be too low, but let's see. And yeah, actually, because we're just adding on 24, the only way to be too low is going to be D. So add on 24, you'll get 48 girls, 56 girls. 54 plus 24 is going to be 78. 44 girls. Otherwise, that could have been a problem. So 44 girls, add 20 and 24, and then 60. So you get 96 total students. Well, that's allowed. 64, that's too small. And the other ones here that we'll work out are big enough. 88, 72, and then 78 plus 54, 132. All of those ones are allowed. Only D cannot happen. D, you would get too many boys, therefore too few boys, therefore too girls, and the total would just not be enough. Okay? So the way we did this, we did a little bit of algebra to understand and solve for the number of girls. That way it was just boys all throughout the whole thing. That way In a moment, we could get single equations and solve for the number of boys. And the way we did that is by understanding how ratios work. That if two things are in the same ratio, you can sort of do this cross multiply, although I know a math teacher who hates the term cross multiply, but that's the idea, is that you sort of swap things, swap the numbers, and then the products are equal. Get single equations for B. Once you've got your B's, you then get your G's, you get your totals, and there we're done. And D is the one that is too small. Not enough students in that case. So that was an interesting little question. I can't remember the last time they had a 25 that had some ratio properties or something in it. That was pretty cool. That was a good paper overall. So that was the 2013. If you're looking for more grade 8 Gausses, did the 2012 in the past. 2014 would be the next one after this. Feel free to browse around the channel. If you're looking for something easier, grade 7 Gausses are a little bit easier. If you're looking for something harder, of course, we've got Pascals for grade 9. And yeah, I think that's it. So I will see you for more math contests in the future, whatever math contest you choose. And have yourself a wonderful, wonderful day.